And next up is Dileep Rao. He is the Vice President of Research at the AI Foundation. So please join me in welcoming Dileep. Dileep?
Hi, thank you.
There you go.
Hi, everyone, and thanks for coming. My name is Dileep, and I work at the AI Foundation. At the AI Foundation, we work on a variety of generation and detection problems using deep learning and a lot of other technologies related to it. And particularly the problems that I'll be talking about is actually on deepfakes. The problem that Michelle was mentioning, like about disasters in social media, reminded me of another kind of disaster that is actually happening in social media today, which is that of misinformation. So today we are going to look at some solutions that AI Foundation and our partners are working on this misinformation problem. So it's not a surprise to anyone today that any video content that you see can be questioned, and the word deepfake itself has become a household term, right? And so we all know that seeing is not believing, and the same thing applies to hearing as well. So, and if you look at some of these examples, these examples you might have seen on the internet, for example, and some of them are very cute and funny. They appear even in comedy shows, and many of them are like downright scary, right? And the same thing applies for audio as well. Like, it's not just visual fakes. Speech today can be cloned to the likeness of your voice in a way that was not possible before. And this has been used, the technology behind this, like voice synthesis, or speech synthesis and voice conversion, they have existed for years. And it's only today that we have these new technologies that allow us to produce voice in the likeness of anybody's voice signature. And this has been used successfully by people to rob banks, to mislead executives into signing fraudulent wire transfers. So this is kind of brewing an information credibility crisis, if you will. And there are, I would say there are two sides to this credibility crisis. One is our inability to trust the real world. That is, basically, it is coming from this ability to show anything fake and call it as real. And the other is the opportunity for plausible deniability, where we can we can basically refute anything. So it's basically our inability to show something real as real. So, and you can always say, oh, this is fake, right? And how do we counter that? So this is actually a real problem. And fake media is not new. So the image on the left is something that you might have seen in a lot of classrooms, right? So this is Lincoln standing. And this is not Lincoln, actually. It is actually, when they were trying to find a standing portrait of the president, they couldn't find any. So they took John Callahan standing portrait, and they just put his face on it. And this has been the standing portrait of Lincoln that we use everywhere, right? And this is not any secret. Everybody knows this. And then Photoshop has happened, and we've come a long way from this. But then, in the last few years, things have gone into a sort of Cambrian explosion, if you will. In 2014, we are able to generate images that were black and white with very low resolution, and it was very hard to make the details of the face clear. And as we progress over the years, it is becoming, we're pretty much, crossing this uncanny valley. And today we are getting to a place where we can generate images of, or generate faces with very high amount of detail. So, and there is also another interesting exponential growth happening, and that is of social media. So as social media adoption is increasing, so is our capability to share it with share or distribute messages exponentially is also increasing. So virality is becoming a new phenomena. If you just think about it, going viral did not exist before social media, unless it was printed in mass media before. And so this is coupled with a lack of education and media consumption. We never went to classes where we learned how to consume media on the internet. So all these three things, the exponential growth in generation technology, the exponential distribution capability that comes with social media, and the lack of education in how to consume this kind of information is fueling this perfect condition where what I call as the misinformation singularity, where you get into a place where you don't believe anything you see and hear, unless we do something about it. So the question is, what are we doing about it? There are a lot of people who are working on this problem. I'm not saying only AI Foundation is doing this, but I'm going to focus on some of our solutions. We're starting with the 2020 election. We're building this platform called the Reality Defender. And the goal of Reality Defender is to become a formidable tool in this fight against deepfakes. And not just the video deepfakes, but also audio fakes and so on. To unpack that a little more, the goals for Reality Defender is, one, to bring the latest and the greatest from AI research and forensics research to production. A lot of the work today exists in laboratory conditions, in the sense that you cannot take the code that you have from a researcher and then deploy it in a product setting, because in the real world, the distribution of the input data keeps changing, and many of the modeling, et cetera, and the state of the art that we see are built under IID assumptions, right? And then what is really needed and what we are working on is to create this interdisciplinary collaboration between academia, technology, startups, and the entire technology ecosystem, including large cloud companies, as well as the government, because we need the government actually acting and working with these companies and with academia, and also the media and entertainment industry. These are just a few of the many stakeholders who are impacted by this deepfake and misinformation problem. And the other goal we have is to build accessible tools, build tools that not just somebody who has a PhD can use this, but also some tools that could be used by journalists, fact checkers, and anybody who's actually interested on a self-serve basis. And so you can see how scaling something like this from something that I did in my lab to something production worthy that everybody can use requires a lot of participation from people, as well as a lot of compute. And finally, another goal of Reality Defender is to push the boundaries of science around misinformation research. And we're doing that by establishing not just these collaboration with academia, et cetera, but also creating data sets, resources, and models and open source code and so on, to advance science and to have and sponsor conferences and things like that. So I'll walk through some examples of the work we have done under Reality Defender. In 2017, we funded the Technical University of Munich for the creation of the face forensics dataset, which is the first deepfake dataset that was ever created. And the goal here was to build a large enough data set so that modern machine learning methods could be utilized to build models for countering deepfakes. And of course, many of these deepfakes produce artifacts that are very similar to the compression artifacts. So it is important to generate this data or create this data set at different compression levels. And this is the first time something like that was done. And as a result of this, we produced a lot of models that can do deepfake detection, but still under laboratory conditions, right? It's not in production. For instance, we could learn a model that can detect a deepfake very well as long as we know the method where that was used to produce the fake. But if you have a new method or a lot of examples from a new method, it becomes, if you don't have a lot of examples from a new method, then it becomes really difficult for the model to produce good results. And not just detection, we are also interested in identifying the exact area of the image or the video that is manipulated. And this sort of model, being able to explain the prediction of the model is crucial in earning trust of the users, because you can't say, oh, this piece of content is fake and just leave it there, because people will not trust your system, right? And segmenting and identifying. So here you can clearly see we are using some kind of a computer vision segmentation algorithm, and with the segmentation algorithm is specifically focusing on areas that are manipulated. So then this is another area of work where we looked at this problem of changing adversaries. So we have all these different methods for generation of fake content. And then when we train a model for detecting a deepfake and try to use that model on this new adversary, the model fails. So the question is, how can we quickly bootstrap models for these changing adversaries, right? And here we use transfer learning, and our approach is called forensic transfer. And in the paper we show a very simple example where, let's say you're from the Department of Interior and you want to know if certain images of forests and all these other national parks, etc., have been faked, manipulated in some way to mislead people, right? And you have, so this is a brand new misinformation problem. But let's say we have a model of fake faces that can, model that can detect fake faces. Then the question now is, can we use this model to quickly adapt or quickly fine tune a new model that can detect manipulated, geographical areas. So that's called forensic transfer, and we've been successful in doing that. And we just take a few images, in fact, less than a dozen images, to quickly train and increase the accuracy of the model, right? And obviously, this works not across domains, but also even within domains. So let's say if there is a new fake generation method comes along, then we can apply this as well. And so these were some examples that I showed that were purely using pixel level information for detection of fakes. But then there are a lot of other interesting information that is present in a video that could be used, for example, like context. So I'll give some examples of algorithms we developed with Professor Hani Farid at UC Berkeley. And so here we look at two different signals. One is the orientation of a person's head and what the person is speaking. And we kind of extract a behavioral signature of a person's head movement when they're speaking. And this actually is true, because when we speak, we tend to have similar head movements for the certain kinds of sounds we produce. And if there's a mismatch in the head movement versus the actual sound that is being produced, then we can detect that, and that can be used for discriminating fakes in a very pixel-independent way. It's remarkable. And obviously, we can do that even with facial expressions. So in this case, we use the FACS encoding, which is facial action coding system. And we can extract expressions, and then can expressions be used to create a signature for a person? And can that be used to distinguish whether a particular piece of media was tampered? And this is interesting because we have, especially in the context of the elections, there are several people of interest, right? The presidential candidates, for example. And you want to be able to identify any tampering for these special candidates. So these are like, people of interest models, as opposed to the general purpose models that we talked about earlier. And these models tend to be a lot more accurate. And finally, there are all these, so all the examples we saw so far were for for video and image detection. We can also apply the same methods or variants of the same methods for detecting audio fakes. So in this work, what we are doing is using a convolutional network and using both multitask learning as well as transfer learning to quickly train models for different kinds of audio spoofing methods. And we are able to detect manipulations in audio with very high accuracy and with very little amount of data. So for example, going from, let's say, one attack vector to another, we can now cut down the amount of data to around 6%, which is like a couple of minutes worth of data, right? And that's incredible. And we are also releasing a brand new data set around detection of audio fakes. And this data set will have around 500,000 examples from a large number of speakers, as well as one thing that we wanted to make sure was the data set was very diverse demographically, so that way the models don't end up becoming biased towards a specific category. So far, I talked about various machine learning approaches for dealing with misinformation. But machine learning approaches are just one, in fact, all kind of software-based approaches are just one kind of arsenal in the artillery, if you will. There are other two parts of this puzzle, or the solution puzzle, that is education and policy. I'll briefly touch upon that, and we're actually talking to policymakers as well as people who are in the education space. But I think it's important for all of us machine learning and data science practitioners to actually become aware of some of these efforts and actually see how they interact with the kind of technology solutions that we are building. So I'll first start with education. So as I mentioned earlier, we at least when I grew up, I never took any course on how should I be reading Reddit, for example. But on the other hand, today we can create new content, new courses specifically tailored at high school students, university graduates, undergrads, and to actually ask them how can we examine a piece of content in the context it was created, right? Or in the context it was shared, and what is the credibility of the source where they got the content from? How was the content constructed? Was there any bias in, or what are some like loaded words, biased terms that people use in describing content, describing any content that can make it very one-sided, if you will? And then how to corroborate, whatever you see with other sources. So what do other news sites say about this, and so on? And what are the tools for doing that? And then how to compare, right? And also compare with your friends and colleagues, right? And there is, I want to give one very shining example of this, which is, it's not a PC name. It's called Calling Bullshit. And it's a very beautiful course. It's available for free for everyone to take. And it's created by Jevin West, who is a professor at University of Washington. And now this course is being taught in a lot of different high schools and even in university level. And the goal here is to see, okay, can we spot misinformation when we're consuming news articles, scientific literature, or any kind of social media post. So then there is this other big part of the puzzle that is policy. So there are so many things here that I'll never have time to discuss, but there are a lot of questions than answers, unfortunately, or fortunately, depending on your view. So how should information safety be enforced, right? Can we just let people just consume whatever they want, right? So the other side of the question is, should it even be enforced, right? So, and then should there be some sort of overseeing body at the federal level that should do this? Or how should this happen? How should this governance happen, right? And then what are the laws around this, right? So if somebody creates some misinformation, what are the consequences for that, right? So what is the legal and policy scholarship? And people are working on it. And there is a law that got passed in California, for example, where, basically it's almost a ban on deepfakes without creating any kind of context. And a similar deepfake ban was enacted just a couple days ago in China. And this is interesting because on the one hand, we really need this kind of legal frameworks for understanding these different kinds of media misinformation attacks and misinformation, or dealing with these misinformation attacks and forgeries. But at the same time, there is always this danger of overreacting and overreaching, especially legally, because and act laws in a way that can stifle innovation, right? And this overreaction can come simply because we don't yet understand what is in front of us. And that's dangerous because once something gets enacted as a law, it takes several years for the law to change, whereas innovation requires rapid changes, right? So we have to, on the one hand, we need to have these legal things in place, but on the other hand, if we don't, as technology industry, if we do not participate at the level of policy and governance, then we will risk getting our innovation capability clipped in some way. So I want to say that deepfakes are here to stay because starting from these toy project, projects that you have seen, like coloring the horse into a zebra, etc., or turning the day into night, and so on, to the kinds of products that AI Foundation and other company are building. The thing on the right is an example of a deep fake that was generated completely from scratch, and it can talk and do anything you want to make it to do, right? And this is, as you can imagine, these sort of technologies have a lot of impact on education, on entertainment, and they can open up new applications in ways that we cannot even imagine today. It's kind of like internet. Internet opened up whole different kinds of applications that people who created the internet did not even imagine. So we cannot afford to curtail innovation in this space, but at the same time, we cannot also be complacent. We have to act responsibly, and we also have to act with care. So I'm going to leave you all with this message, but I really hope that this talk is not the end of this conversation, and I hope you'll all join me in this conversation later as well. And I also want all of you to come and work on these problems, because the scale of problems that we are looking at is not like a single startup or even a single big corporation level problem, but these are gargantuan internet scale problems. So with that in conclusion, I really thank you all for coming and for listening, and it's been a pleasure. Thanks.